So in this video, we're going to be working on percent abundance problems for different isotopes of different elements. So let's go ahead and look at number 9. So it says naturally occurring boron consists of 80% boron 11, and here we have the mass is 11.01 atomic mass units, and 20% of another isotope. Boron has an atomic mass of 10.81 AMU. Find the mass of the other isotope. So we're going to be using that same equation where we take the mass for each isotope. So let's do the first one. The mass is 11.01, and we're going to multiply it by the percent abundance. Alright, so this represents for boron 11, and we want to find the mass of the other one. So let me go ahead and introduce a letter here. I'm going to use M to denote the mass. Now, if this is 80% in terms of the percent abundance, then this one would have to be what? Well, we only have 2 isotopes. So if 80% is of this one, that means 20% has to be of the other one, because these percentages have to add up to 100. So 11.01 times 0.8 plus some mass times 0.2 equals, and then the average atomic mass of boron, which is 10.81. Okay, so now we can go ahead and simplify our math here. So we get, let's get the calculator, 11.01 times 0.8. So when you multiply these, we get 8.808 plus 0.2 m equals 10.81. Then we subtract 10.81 minus 8.808, and this will give us 2.002.2 m. Okay, so we're just doing some algebra here. Then we can divide by 0.2, divide this by 0.2. We get that the mass of the second isotope is 2.002 divided by 0.2 is 10.01 atomic mass units, AMU. Alright, so that's how you do that question. Let's go ahead and take a look at, that one was 9. Let's take a look at 10, and then we'll jump to 3. So for number 10 we have naturally occurring argon consists of 3 isotopes, the atoms of which could occur in the following abundances. So for argon 36, and here you have this hyphen notation. You see how it says argon hyphen 36. So this number 36 is the mass number that we're working with. So this is our mass number. So let's go ahead and do that one. So it's going to be 36 multiplied by, now this is saying 0.34%. So be careful, we need to write that as a decimal number. So we would scoot the decimal 2 places to the left. So do 1, 2. So we get 0.0034. So that plus, what's the next one we have? 38. So that's, again, we're using the hyphen notation. Argon 38 means the mass that we're working with is 38. And then multiplied by the percentage, but written as a decimal. This one is 0.07, so that would be 1, 2. So we get 0.0007. And then plus the third one, which is argon 40. So again, the 40 is the mass number, and then we have to write 99.59 in as a decimal. So that's 0.99 9959 equals, and then the average atomic mass. So I'll just put M, just use a variable there. So now all we have to do is just type all this in the calculator. So 36, let me do it like this, 36 times 0.0034 plus, and then 38 times 0.0007 plus 40 times 0.9959. Okay, get enter. So we get that the average atomic mass is 39.985. So whenever we're solving for average atomic mass, we can always check our answer by looking at the periodic table of elements. We go to, in this case, argon, and we look at the mass number at the bottom. That represents the average atomic mass, so we should be getting that number there, or something very close to it, depending on the rounding with significant digits and all that. Alright, so we got that. And then we can finally do number 3. So let's see. It says chlorine has an atomic mass of 35.453 and 2 naturally occurring isotopes. Isotope A has a relative mass of 34, so I'm going to put here 34.96885 and an abundance of 75.53%. So again, this mass for isotope A multiplied by percent abundance written as a decimal, that's 0.7553. That's for isotope A, and then we're going to do plus. We want to find the mass and the abundance of the second isotope. So this question is very much like question number 9. So I'm going to put M because we don't know what the mass is, but we do know what the percent abundance is. Since there are only 2 naturally occurring isotopes, then we're just going to take that 75.53% away from 100, right? So 100 minus, or you can do 1 minus 0.7553. Both of them give you the same thing. So 75. Just make sure to convert things to decimal when you actually work with a calculation. So I get here 0.2447 equals, and then the average atomic mass is 35.453. 0.453. So now we just type this in the calculator. So it's 34.96885 times 0.7553. This gives us 26.412 plus, and then this is just 0.2447 M equals 35.453. So now we can move this to the other side of the equation. 412 cancel, minus 26.412. See what that gives us. 35.453 minus 26.412. So that is 0.2447 M equals 9.041. Then we finally divide 2447.2447, so we get M equals 9.041 divided by 0.2447. That gives us 36.9473 atomic mass units, if you want to put the AMU. And there you go. That's how you do that.